So you've made all of these rockets, and you've launched them all of these times, and you're sitting there and asking yourself, why doesn't my rocket go the same distance every time? So here we are, we've got my rocket. This is the one that I made. It's the same rocket every time. It's this control design, and when I launch it the first time, I might get this distance, and then the next time it's this distance, and then the next time it's this distance. What's up here? What's causing these big differences for the same rocket? Now, of course, you can talk about how much you're blowing into the rocket every time, but even if you blew in exactly the same every time, you wouldn't get the same distance. And let's figure out why. So let's take a look more closely at our rocket. Here it is. But it doesn't look quite like this. Let's say we put on the tape just a little bit askew. See this right in here? Well, let's go ahead and load this on our launcher and see what happens. So there's our launcher. We'll quickly pop it on. Let's change the camera angle so we can watch it go up. And then, ready, 1, 2, 3, blow! It goes up, and, well, as it's going up, of course, there's all sorts of air rushing past it. And let's watch some of those air molecules rush past. Well, there they go. Boom, 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 boom. And let's take a look in particular at this one. It goes, and it hits our little tape that's sticking out. And when it does that, that tape basically acts like a little handle for the air that was going to rush past the rocket, to grab onto the rocket, to hit it, to collide with it, to transfer energy to it, and to push it off course, because it's only grabbing onto the rocket on one side. And you know that when things are pushed from just one side, they're going to rotate. So let's watch this rocket go up a little bit higher. It's going to be pulled this way, and there it goes. So that was when we put the tape side up on the launcher. One of the things that you may not have done the same every time is you might not have put it exactly on the launcher exactly the same way every time. So what happens if you put it tape side down on the launcher? Let's do that whole thing again. Let's load it up here onto the launcher. We'll move our camera angle. We'll fly away here. We'll look at the air rushing past. Those air molecules are going, and then this little bit of air here is going to collide with the tape again, but the tape is on the other side. And so when the tape collides and it pushes against that, we're going to set up a rotation of the rocket again, but the rotation's going to go the other way. Look at the difference here. When the tape was on the top, we went and rotated one direction. When the tape was on the bottom, we rotated a different direction. And so each time you load up that rocket, these little tiny imperfections might be in slightly different spots. And those slight differences, as you can see, can cause big differences in how the rocket flies through the air. So our rockets are full of tiny asymmetries. It wasn't just that one. You know, we have, oh, we didn't fold it quite right. The tape over here is like this tape's like that. And you put all those things together and you get differences. But then, of course, there's even other differences that we haven't even talked about that don't have anything to do with your rocket. The air around your rocket, that air that's going to be interacting with the rocket as it goes up, as it crashes in, that air is moving constantly as well, and it's not always moving the same way. So let's say somebody on the other side of the room walks a little bit. Well, they're disturbing the air. They're pushing the air out of their way, and that tiny little disturbance on the other side of the room can have a small impact on the air movement all the way over on the other side by where your rocket is. And that's going to be different. Let's say two people were moving when you launched the first time and nobody was walking the other time. Different air movement, different interactions with the rocket. And then, of course, if you're outside, tiny gusts of wind can come from all sorts of different directions because of this air, massive air movements on Earth's surface, and they're always just a little bit different. And those little differences, again, can cause big differences in the way the rocket flies. So in the end, every launch turns out slightly different. So this is why it's important to be as consistent as possible. Perhaps we should have lined up that tape all so that it was always pointing the same direction every time. Maybe that would have helped. But we can't control for everything, especially not in a classroom, as you know with your fifth graders. And that's why it's important to do multiple trials and take the average. We're hoping that all those little differences will sort of cancel each other out so that we'll get the big picture. The really important question will be answered. Where is the best place on average overall to put the astronauts when you stick them on the rocket so that it will be more stable? Kind of an important question. And you need to be able to answer that when these little imperfections are not going to affect the results. And the best way to do that is with multiple trials and the average.